Can you see me?
I can.
Really? I can't see me.
You can't see me? You need to stop screen sharing for a while. You may start when we start with the presentation.
You want me to stop screen sharing? Okay.
Mhm. Also, Sam, you might want to just align the camera a bit towards the center because there's a vertical video, so you might not be fully visible.
How's that?
Perfectly fine. All right, we already have 30 people joining in.
Okay,
I'll
here's
wait.
presenter's view. Look at this. But it doesn't show me. It doesn't show me or people.
You can't see yourself?
Nope.
That's strange. What window is open on your laptop? Is it Chrome, Riverside?
Yeah.
Um, that shouldn't be the case. Can you see the controls in the bottom of your screen?
No.
Mic, cam.
Nope. End the screen show for a second. Huh. Ah, there I am.
All good.
All
Okay.
right.
So we'll just wait for a bit to gain a bit of an audience before we start with introductions. And meanwhile, you guys can also ask Sam your questions directly, any questions that might not be related to the agenda of today's webinar. So now might be a good time to ask those questions.
Ah, someone in KL. I love KL. Will this be recorded and placed on YouTube? I don't know. Are you going to place it on
Yes,
YouTube?
it's already live streaming on YouTube.
Oh, it's already live streaming on YouTube. Wow.
We have a few people on YouTube already.
That's great. All right, should we get going?
Yeah, we have 30 people already, so we can start. Just right before, just a couple of points I'd like to mention for our audience.
My
Um,
voice is very low. Hold on. I'm going to pull up a mic.
Sure.
I have a better mic. If my mic is low, I will try a better microphone. Check. 1, 2, 3. How's that?
It's
Is that
still the
better?
same. No, it's still the same. If I'm too loud, maybe I should
Hang
reduce.
on. Let me see if I can change my input. Sure, USB input. Okay, I can turn it up a little bit. Check. 1, 2, 3. How's that?
It's still the same.
Still the same, huh?
Actually, Sam, before we were live, you switched microphones, I believe, right? Before that,
Yeah.
it was louder, but it had some noise as well. So I didn't bother to let you know.
So what you think that's not as good or is better without the mic?
The previous one was louder. This one is more cleaner.
I can
You
make
can try
this
the other
louder.
one. You can
How's
try
that?
the other one.
I can make it louder. How's that? That's louder. Check. 1, 2. Check. Check. I will speak louder.
Guys, are we good to go?
Okay, we're good to go. So let me
might be a distance versus setting issue.
Yep. Okay, let's start this presentation. Great. So, welcome everyone. Feel free to ask questions and let me know what, no, I don't want that.
Yeah. Um, and also, I'll just there's just a couple of points I'd like to mention before we start. Um, One is about like if you guys have any trouble with audio video in case you can't interact with chat either. So one way to reach us out is via the WhatsApp group, right? So most of you, I guess, already are in a part of the WhatsApp group. If not, you can find a link through our website or Instagram, or you can just reach out to me directly. Most probably chat will be able to help you out. If not, that is the way to go. Second, as far as interaction goes, we obviously can't see you guys, which is a bit of a bummer, but you guys, those who have joined from Riverside via a desktop or a Mac, have an option of live call-in somewhere down the bottom of your screen. So during the Q&A session later in the webinar, you might use it if you need to discuss your questions in detail with Sam. And I request you to not use it in the middle of presentation. And before I go to Sam's introduction, Sam, do you want to just give a quick check to the screen share if it's working properly and streaming on both platforms?
Can you see it?
Nope.
All right, hold on. Oh, because I have to press screen share again. Um,
Chongi says it's very muffled and like far away.
I will try and make it closer and less muffled. Check. 1, 2, 3, 4. How's that? Check. 1, 2, 3, 4. You guys can see that?
Yeah, it's better.
Okay, great. Let's get started. So the topic we picked today is probably one of the least sexy but most important topics in studio and concert hall design, and that is isolation, building box in box. Um, the first step in determining isolation details is estimating the amount of isolation you need to operate. I get questions every week from people who call me and say, what kind of walls should I build? And I'm going, what are you trying to do? What are you trying to isolate from? Um, what are the risks of not isolating? What are the risks of sound entering your studio and destroying tracks? What are uh, um, the sound exiting? This is a wrong word here. Exiting your studio and upsetting adjacent neighbors. And then you have to consider isolation not just between one or two neighbors, but in every direction, up, down, sideways, adjacent. I'm currently working with a client who isolated from apartments upstairs and didn't realize that the real problem was going to be next door because the buildings are attached. And he spent $130,000. People upstairs are thrilled because they can't hear them, and the people up next door are ready to file lawsuits. So it becomes a challenge. Um, these are real world considerations. It may be different in India than it is here, but here we have people who are always willing to uh, try to stop you from infringing on what they think are their rights, which is the quiet enjoyment of their premises. So you really, before you start to draw and think about what you're going to do, you need to think about what you need to do, because sometimes it's less than you think, and sometimes it's more. What are the risks of not isolating? Well, I like to work in a studio that can't work during business hours because they have a law firm that's next door, and they've got a judge to tell them that they can't operate until 7 p.m. and they could lose their lease. Um, Trains, airplanes, traffic noise, adjacent industries, all of that stuff can ruin what you're doing, and you need to think about how much risk there is for that. Will you disturb neighbors, and how disturbed will they be? And then uh, one of the things that a lot of people forget about is room to room in your facility. So, for example, if you have a live room and a control room, you're really in a situation where if they're always working on the same thing, you'd like to have good isolation so you could hear what's happening in the control room without getting blown out by sound infiltrating from the live room. But at the end of the day, it's not horrible if there's some leakage. On the other hand, um, if you have a building where someone's going to be setting up for a session in the live room and getting sounds for instruments, and you're going to be finishing up a mix, you need good isolation. So, understanding how you're going to use your studio is an important part of planning this. Um, that's in red at the bottom because it's the thing that people miss the most. Yeah, I think I said all that. The most common technique for studio isolation is box and box. Um, this sounds simple, but there are literally hundreds of variations of box and box designs. That's because there are different types of walls and ceilings and floors and penetration details. And if you spend all your money on great walls and really cheap doors, you don't have much isolation. One of the rules that we learned in school, which has always stuck with me, is that if you take a very large wall and you put a hole 1% the size of the wall, you diminish the isolation of that wall by 50%. I'll say it again. If you take a large wall and you put a hole 1% of the size of the wall in the hole 1% of the size of the wall, you're going to diminish 50% of the isolation. That may not sound like a lot, but think about it. That's a small hole in most walls. So we really need to pay attention to lots of these details: windows, doors, conduits, ductwork. Ductwork is the most overlooked way for sound to get in and out of a room. All right, as simply as it can be drawn, if you have a space, call it the red rectangle, we're going to build an inner room inside that space. And the isolated room, we're going to try and limit the way that the floor, the walls, and the ceiling are attached to the floors, wall, and ceiling around them. You're going to see that there's lots of different methods to do this um, for all of these areas. As I mentioned, floors, walls, ceilings, penetrations. Here's the first question. If you're looking at a facility and you want to isolate the room and you have to add a new floor, new walls, and new ceilings, can the existing structure hold the weight of the box and box? You can calculate that fairly quickly if you assume that the floors, walls, and ceilings are going to be 2 to 3 layers of gypboard and some studs and some fiberglass, and gypboard is, a kilo a square foot. Got to mix up my metric units for you there. It's 2.2 pounds for a 5/8 inch sheet for a square foot. You guys can calculate that. And you can take the size of the room and then estimate what your console and your gear and everything weighs. And you can decide if you have the support you need. A lot of people don't, particularly when they're trying to put heavy duty isolation and lots of equipment into a second floor bedroom in a residential structure. The other question is, how much isolation do you need? Right? How will the isolated floor be isolated from the existing or outer floor? How low in frequency are you trying to isolate? It's much harder to isolate low frequencies than high frequencies. It takes more mass and more um, either discontinuity or resilience, and we'll talk about that. Also, knowing what the resonant frequency of the floor is critical, because if you have subwoofers that are going down below 20 hertz, you need to make sure that your low frequencies are well above the resonant frequency, or the floor will stop bouncing. The other thing is, how thick is the isolated floor? Because you're going to have to ramp up and ramp down. And depending on where you are, there are lots of regulations about what you can and can't do there, particularly in the United States. So here are 4 different types of another spelling error, great. Types of isolated floors that have a resilient element that supports a floor above. So for example, the least effective and thinnest isolated floor for most people, it's just a rubber sheet. You can buy them made of recycled materials, and they range from 4 millimeters to 25 millimeters. Some of them have a bumpy side so that you get less area connecting to the bottom floor, and they come in different densities depending on the importance of low frequency isolation. One of the materials that I love is honeycomb materials, and I use them in lots of floors. We've used honeycomb materials in probably 80 to 90% of our isolated floors for studios over the last 30 years. And these honeycomb materials are very lightweight, they're very cost effective, and they don't block sound. But what they do is give you a discontinuity between the upper part of the floor and the lower part of the floor. And we'll take a look at that. The most common and most effective for the cost is rubber or compressed fiberglass pucks. And typically the thickness is from 25 millimeters to 100 millimeters. I recently had a project with a film studio here in New York City, and we had recommended a 2-inch or 50 millimeter fiberglass puck. And the architect said, "Is there any way to make that bigger?" And I'm like, "Yes, it works better for us. We just generally don't get people wanting to lose the height." And they're like, "We have some conduit that we can't move that's going to go under this, that's 2.5, 3 inches tall. Can we go around it?" And I'm like, "Sure." It worked out great. Springs, the thickness, the size, the capabilities in terms of weight varies greatly, and springs are almost always used for pouring concrete floors, and we'll look at those. Here is some rubber sheeting. This one comes in a bunch of thicknesses, and it comes in rolls from 4 feet wide and 50 feet long or 200 feet long. And they'll tell you that if you lay it on a cement floor that's 4 inches thick and you add that 3 millimeters, you get an STC of 50. And if you gain 9 millimeters, if you use 9 millimeters thickness, you still get STC 50. You also notice that your IIC goes from 50 to 52 by tripling the thickness, which is not a big change. What is interesting is that your IIC, your impact class, goes way up. The delta from without the pad to with the pad is is over 21 points. And the reason for that is almost all of that impact class is high frequency. And so the pads are very effective at high frequency and not so effective at low frequency. And that's why even tripling the thickness of the pad doesn't give you more STC, because STC doesn't really count low frequencies and it's just doing what it's doing. So that's a 6-inch slab with a roll of thin rubber on it. Very cost effective, very easy to install. Sometimes you need to use a um, membrane to keep moisture away from it, but that depends on where you are and how that impacts you. This is a isolated floor that has a honeycomb material, and the yellow that you see is just cheap felt to keep it from being destroyed. Sheets of this are not very heavy. They can pick them up easily. I can pick up 2 or 3 sheets, and they cut with a putty knife. The thing that is really amazing is that it'll take 1,000 pounds per square foot. So if you put, plywood and things on top of it, you can roll lifts on this stuff. 1,000 pounds a square foot is 39.25 kilograms per square meter. It's pretty impressive. This one is about an inch thick, 5/8. I like the 5/8 one. We don't use the 1-inch thick very often, but we use it in unusual ways, which you'll see in this slide right here. So here's a detail. I made it color coded for you. This is a stage structure. We use it as a stage floor for keeping sound out of the standard stage construction. I feel this gives a little fuller bass sound and a little bit more isolation and projection. And the drawing on top here is simply a finished floor, whatever it is, wood. So we have our 5/8 inch honeycomb, which is the yellow, 3/4 inches of plywood, 1/4 inch of cement board, and 1/4 inch of plywood, and then the finished floor. So why use the cement board? Well, what's interesting about this is that plywood doesn't really weigh that much. I mean, it's heavy, but it's about a pound and change a square foot for 5/8, 3/4 inch. So the cement board at 1/4 inch thick is about the same density, but if you divide the weight by the thickness, you get the mass density. And the mass density is really what blocks low frequency sound. So what we're doing is we're building a sandwich of 2 layers of plywood with a layer of very massive 1/4 inch cement board in between them, and we're screwing those together, and we just float that on top of a cardboard honeycomb. And we don't put any screws into the honeycomb because it'll destroy it. So we're careful about that. And we use lots and lots and lots of screws in the sandwich layer. And that gives us a nice isolated floor to work with when you don't need super low frequency performance. Here is a studio that we put into a basement of this is a home of a producer. She lives in just outside Las Vegas. And what we did was we laid out her control room. What you can see, I'm hoping you guys can see my mouse. This is the front of the control room. This is the live room. There'll be a vestibule off to the right side. These are people talking about what we're doing. And so we laid down the honeycomb in each room and then cut a gap. So there's a, can I zoom in on this? You can just kind of see that there's a gap here. I think maybe, yes, you can see it better here. And we left the gap and we're going to build another isolated floor here. The gap between these is key to achieving great isolation between these rooms. And there'll be a wall, stud wall sitting on this isolated floor and a stud wall sitting on this isolated floor. And similarly, there'll be a stud wall sitting on the vestibule, which can be used as an isolation booth. You'll notice that all of the joints are staggered. So we pick a datum point. In this case, we pick the rear corner of the room, and we put up a little piece of the cheapest, least expensive foam we could find, just so that stuff doesn't fall in there during construction and bridge our isolated floor to the existing walls. We filled in all of these holes and so forth. But this space will be entirely box and box, and the live space will be entirely box and box, as well as the vestibule between them. This is a very effective thing because in a ceiling, that's the maximum height that we can go to, and we want to keep our isolated floor thin. This is also on grade, and there's very little chance of sound going down through the grade onto the ground, through the ground, and over to the neighbor. That's not something we were worried about. Here's another view of this, and you can see how we have this foam against the wall to keep our gap, and you can see the staggering of the joints, and I think that's all that really shows. This is a little bit more interesting. This is an alcove for some storage and some shelves that we were building into the live room of the studio. And instead of making it part of the control room, we made it part of the live room and gave them a little storage space, which I think is really useful. You can see here the stud tracks are laid down at the edge of the isolated floor. And if we look at this one, the foam shows you the gap between the isolated floors. There's a track for the live room that goes all the way around here and all the way around the front of the control room, and then inside the control room. And inside the control room, this is an alcove where we put racks. So when you're sitting in the control room and you look to mix right, you have in-wall racks. I'll show some pictures of that in a little bit. It's really important that the walls on adjacent floors have no rigid connections between them. This is really, really critical. This is a guy who I really like. He lives in Denver, Colorado, which is out in the West, and he built a studio part-time by himself with the help of his dad and a couple of friends. And we laid out the spaces, and instead of using plywood, he got a great deal on particle board and wanted to use that, which was fine with me. There's the cement board, and you can see the piles of SR, the honeycomb in the back there. Sometimes we've had to use things other than the cement board. One of the venues that we've done has bowling alleys where you roll bowling balls down, which thud quite hard. They weigh 10 to 15 pounds, and people throw them down the lane, and cement board doesn't take that kind of, it'll crumble over years, and then the whole floor will stop working. So we used a very heavy doped vinyl that we found that worked for that. The most common type of isolated floors in studios are either compressed fiberglass pucks. You can see one cut open here where you can see the fiberglass has been compressed and encased in a membrane. And here you have um, uh, uh, um, rubber pucks, and both of these are generally have isolation filled in so that there's not a hollow that doesn't resonate. One of the things that I try to do is not do 3 layers of wood, but try to get something with more mass density, right? So it doesn't matter if it's a puck or fiberglass or rubber puck. In this case, it's fiberglass puck. We put fiberglass in here so this area doesn't act like a drum. Then we have plywood. Then we have SR board. That's the honeycomb. Then plywood. And then this layer is either cement board or uh, uh, very heavy doped vinyl, and then plywood, and then a finished floor. But the idea is to get some mass density. And I think what's interesting about this is that this doesn't work as well because even with uh, the plywood, you have less mass density and you're helping the pucks by putting something heavier than a third layer of gypboard on there. Third layer of plywood, sorry. This is the first time we used this system, and the reason was this was for a university in New York City, and the studio was being run by the great recording engineer um, Jim Anderson, a wonderful engineer, and he called me up and he said, "We just found out that the people below us are going to be a law library and the people above us are going to be a law firm. So we have to have really amazing isolation. And you can really see these are 2-inch pucks, kip pads they're called in compressed fiberglass. Uh, the plywood, the honeycomb, the plywood, whoop. The cement board is the gray, more plywood, and then the finished floor goes on top of that. Then the studs will sit, it's a little bit hard to see, but there's some foam over here to keep this off the wall so there's no connection. And then the studs will go up and we'll talk about what we did for a ceiling there. You'll notice that there's some existing ductwork that we are not allowed to move. So we had to accommodate that, and it required some really interesting details for um, the ceiling. Okay, let me like that. Again, another little thing. When you're picking kip pads, this and or rubber pads, this is really important, and most people get this wrong. And I'm not going to yell at the company who did this because they're trying to be helpful, but it's an incredibly hard chart to read. They make 1, 2, 3, 4, 5, 6, 7, 8 different types of these pads. And I try to stay away from the heaviest ones and the lightest ones. And here is the percentage of unloaded thickness for a given wave, right? So you're gonna, the initial static deflection, this is when you put a floor on it, but don't have people jumping up and down or all of the equipment. So what they're saying is in these darker areas, that's the operating portion of the puck. The weight in pounds per square inch which is really a crazy unit to use. Um, why not pounds per puck? Because they have different size pucks and they tell you how to, oh, sorry, they tell you how to do that. We almost always use type Q or type QR. And the reason for that is if you think of a 2-inch puck, that's 2 by 2, right? That's 4 inches. Um, that's 50 millimeters by 50 millimeters, right? So you can calculate the kilograms per square centimeter if you need to, but what you're looking for is something, even type L is okay. If you think of uh, 3 layers of plywood and a layer of cement board and another layer of 3 layers of plywood, cement board, and finished. And if you average that to 2, that's about 8 pounds per square foot. But we're going to sit our sidewalls on it. And so we're going to try and get this by screwing it together to act as one giant um, push down. Uh, so, and we'll take care of the edges. So if you were to have, you know, 25 to 30 pounds per square inch here, right? Um, you could use a type Q, but you wouldn't get enough static deflection on a type QR. And you could use a type L, but they're going to start to get a little spongy. And you're not going to have, depending on what the sidewalls weigh. So you really have to go through this chart carefully. And this is probably the trickiest part of working with a rubber or a fiberglass pad. Um, I have a bunch of spreadsheets. I guess I could post them um, that allow you to put in sizes and constructions, and it spits out the options for you. The other key factor is the um, natural frequency. And this one is, whoa, stop doing that. This one is particularly interesting. And you'll notice that these natural frequencies are very high. And what happens is these numbers are for a 1 inch by 1 inch puck. And then you decrease those by, depending on the size, let's say 50% for a 2 by 2 and 75% for a 4 by 4. So if you have 10 pounds uh, per uh, square inch on your pucks over here. I'm looking at type L over here. And it's going to be 16 pounds for 16 hertz for a 1 by 1. It's going to be 8 hertz for a uh, uh, for a 2 by 2 and below that. So it's very reasonable to get a low frequency. But you really don't want something that's spongy if you're going to put a subwoofer on this floor, because the floor is going to bounce. And that is not a good thing, particularly when it's holding up your walls, which are holding up your ceilings. So these two, this is called the static deflection loading chart, right? And it this is the natural frequency versus static load for, excuse me, these kip pad isolators. I refer to these on almost every project that we do an isolated floor, just to see where we are and make sure we're not getting in trouble. This is what it looks like in practice. These pucks come in a roll with fiberglass. So when you get it, you cut it open and you roll it out, and you can do a room in 45 minutes. You lay down your plywood, you stagger the joints with your honeycomb, you lay down another layer of plywood. You can really see the particles in the cement board, and you have another layer of plywood. You screw these top through together with as many screws as you can get through them. Um, just get someone with knee pads and a screw gun and screw away. Use a bucket. The more this acts like a single membrane, the better. You'll notice this one, is a little bit close to these two. Whoop. Um, and this is really interesting to me. What we're going to do is we're going to put a stud here on top of this. So the stud has a lot of weight and we don't want this to deflect. So we put an extra stud along an extra kit pad, an extra isolator underneath, and we calculate what that has to be. And you can really see that I put the green arrows here. So these are on standard centers, right? And then here, there are some extra walls. And here, this is the big, heavy extra wall that's going to jog around. So we buy extra kit pads and we lay them down. And you can see the white foam gives this a gap, usually an inch and a quarter, an inch and a half. And you can go up with your stud once you put down this. Now, yes, this does compromise the floor a little bit. We put down a heavy, heavy, heavy piece of rubber underneath this junction box. We put down a piece of SR on top of that, and there's the junction box. This floor, this is 2 inches thick, so this is almost 6 inches thick with a finished floor. So this is a 4.5 inch thick box. All of the conduits come in. We call this the octopus. These are in the live room. These are in the control room for this case. And we drew where the studs and the walls, the insides of the studs and walls are going to be so that we could, where the boxes where they need to come up, so that we could put those in the right place. The amount of diminishment or degradation of the isolated floor is really nominal. If you don't use a built-up floor, you're going to use what are generally called jack-up slabs. And that's where you put these different types of isolators into the floor, on the floor. You put rebar down, you put a form down, and you build a concrete floor, and then you open up the top of these, and you get 30 of your best friends to come over and turn each one of the screws inside there a quarter turn at a time, and you raise this up a couple of inches. I have some videos of that, but I couldn't find them on this computer, so I'll post those in the future. It's fun to see a slab come up, but you can't just turn it at one end, it'll crack. So it's 1, 2, 3, quarter turn, 1, 2, 3, quarter turn, and everyone's there for a couple of hours or more. These are from Mason Industries, a great company that makes a lot of really good products. I like their stuff. This shows you how this particular one works with spring and neoprene and has a top plate so you can access it and then you never have to see it again, and it raises up the concrete slab. This is the
Sam, before
rebar.
we conclude, do you think we can take a question?
Yeah, of course.
There's a good question asked by Lucas, who is joined from YouTube. Question for Sam: is an isolated floor really required on a basement slab? Will the concrete slab actually transmit vibrations to the rest of the house?
Ah, that's a great question. In general, when we're building isolated floors on a base slab, there are a couple of reasons. One is that slab is sharing footers with uh, adjacent rooms that are not part of our complex, and two, we don't we also have, for example, to go back just here, well, I went too far, to this one, if there's a control room here and a large studio here, they wanted to be able to do full recording production and live broadcast out of this live room and work on separate things in the control room and not hear each other. That's very similar to the New York University room that we did, where they needed to teach two separate classes, both that get loud, and they didn't want to be disturbed by the other class. So when you're on grade, it's not as much of a problem. However, on this side of this room, can you see that column? I can pull up some more pictures once we're at the end. I'll just go to project folders and pull up fun pictures for you to see. This room shares a wall with the upstage room, the upstage wall, I'm sorry, of a 200 seat concert venue. And early on in the programming, I don't know if you guys know the band Los Lobos, but they're a wonderful band based out of LA, and I love those guys. And they were playing up in the live performance space upstairs, which shares this wall on the right side here. And we had a string quartet recording Bartok string quartets in here with lots of open condenser microphones. And the question was, could you have a rock band on one side of the wall and a string quartet on another and not destroy the string quartet's recording? And I wasn't sure, because that's a lot to ask. And it worked just fine. It was actually, I was surprised it worked as well as it did, because Los Lobos tends to get loud. They were at about 108 dB at the mix position and probably 114, 116 on stage. So it's only a 200 seat room, but they were loud. And so this was designed specifically for the adjacency to the right and the adjacency to the control room. I hope that answers your question.
Also, I would like to add some one part to this, and Sam, please correct me if I'm wrong.
Yeah,
Uh, there's a very common practice of thinking in acoustics that slab on grade, if this is just a slab on earth, it doesn't need to be isolated or floated because the earth acts as a stiff damping mechanism. But I've seen quite a few such projects fail because either the earth beneath the slab was not soil, instead a solid rock,
that's
which
right.
lets transmit to the roads and then to the buildings,
Yeah,
or the soil was too wet, the groundwater level was very high, and after the casting it creates cavities beneath the slab.
that is correct. The other thing is that in the U.S., we're going to open this studio. I have some pictures coming up in this presentation, which is underground. And we did isolation on the floor because there's so much rock in the ground and there are neighbors. And when you're building underground, adding an isolated floor is such a small amount of money compared to what it costs to dig and build caissons. And but the other thing was, it's another studio where people come in and work in the control room on mixes while people are working in the live room. And without two isolated floors, forget it. It's not gonna work, because the just the connection to the floor is not going to stop sound through the walls. Okay, so there's your jack-up slabs. There's a spring jack-up slab sort of exposed, shows you the rebar and the concrete. These are fun to do, but again, it's costly, very costly. Um, I drew this so you guys could see what this looks like in a drawing, right? And I think this is really interesting. I don't know that can I draw on this? Oh, I can. Look at this. That's my isolated floor, the yellow. Can you guys see that? I don't know if you can see that.
Yep. Clearly
Right?
visible.
Right. So here's a nice blue. This is where my stud is. Oh, I wanted a highlighter. I didn't want to.
Sam, are you referring to something else other than the drawing? Because your mouse was moving somewhere else, I think.
Yeah, I'm trying to get this to do what I want it to do. I keep hitting the wrong thing. It's being anyway. You guys can see this where I drew this blue line. This is the stud, right? And this is that piece of foam. So we put a piece of foam down. We lay down the acoustical floor, and you'll notice that our note says varies with type. For our general details, we don't know what we're going to do because we haven't heard what the client wants. We're giving them some standard construction details, right? And um, here we're showing 3 layers of chipboard and insulation inside of this. And if we zoom in right here, you're going to see what's called a unibrace. And a unibrace is this piece, which is called an isomax with a flange. And what that's acting is the inside of this is rubber, and you put as few of these on the wall as possible to hold this for earthquakes and for other seismic events. Um, and so the idea is you want to use as few of these as possible, and generally you don't want to use them down low in the wall because if this is your point of where gravity is using your fulcrum point, um, the big forces are going to be up top, so you're going to hold it in place. And then what we do is we run studs between the sidewalls to do a spanned ceiling. You'll notice that there's no connection at all between this ceiling and the structural ceiling above. There's only limited connection between the walls and the demising or existing walls. There is a connection between the floor depending on the type, but if you're using rubber or fiberglass pads, those pads limit the area. If you're using 2-inch pads on 16-inch centers or 24-inch centers, you know, that's a small fraction of the total area that's connected. So you have limited connection here. You have a heavy, massive surface that's blocking sound. You have a heavy 3-layer massive surface with 3 or 6 inches of fiberglass here, an inch and a half, and then the existing wall. And here, the ceiling, you have nothing going upward, no connection at all to the ceiling above. That's pretty awesome, right? So in this box in box where you don't have a hanger for the ceiling, you can use these span ceilings, and we'll take a look at that. Now, one interesting thing is that if you look down here, you'll see scheduled finished floor, and our scheduled finished floor has to go in after our chipboard has been installed. And you'll notice my draftsman got this wrong. It's supposed to be under the 3rd layer to give you a really good seal, but that's not really important right now. The other thing we do, and you guys are welcome to steal this from me because I didn't invent it and I just adopted it 30 years ago, is when I draw a wall, this is in section, right? We're looking at a cut through the room. We flip this 90 degrees so you can see the top of the studs. And you can see that the studs are on 16 inches. And here's a unibrace by Kinetics that shows it's being attached here. That's the same thing as looking down on this. So you're looking down on this middle section. Architects and contractors really appreciate when you make your drawings well called out with good notes, with lots of details so that they don't have to call you 40 times to get information. And what we do is we give them a floor detail and we'll reference it once this wall is, once the floor is determined. Here is what happens when you have two walls next to each other that are both critical, say a live room and a control room. If we go back here, this side would not be a sound critical side. There's no isolated floor and just a standard wall here. This is the side that you're trying to contain sound in and keep sound from going out, right? So what you have to do is say, all right, where do I need to put my walls? And in this case, we have two separate floating floors. See if I can get this to work again. There's one floating floor. And can I get this to change color? And there's another floating floor, right? So these floating floors never touch. And the only thing between them is some cheap foam. And that foam becomes important, particularly when you're doing walls, because stuff falls in and fills that crack. And all of a sudden it's one floating floor and sound can get through it. So keeping that clean and free of debris during construction is important. Keeping that gap real is very important. Here's our section looking down. You can see the studs. You can see one of the little sway braces. Here you can see the studs or the joists going across. And in this case, we have 2 layers of gyp instead of 3. I don't know why, because we did. I can't remember what this particular detail was from. This is what it, This is what it looks like in person. So this is really interesting because what we asked them to do was to build the walls for this studio. And this is an underground bunker studio. So the floor, the walls, everything are concrete. This is the control room. You're looking from the front towards the back. And we went across. Does anyone want to know why we went across instead of the long way? Anyone want to venture a guess? It's really stupid. It's shorter. You can use smaller studs. You want to go the short way whenever you can. This ceiling slants upward. You can sort of see that here, and then it hits a spot where it goes straight because we ran out of ceiling height. So we splayed this ceiling, and you can see these are slanted downward slightly, and these are straight across. You can see it here as well, straight across and slanted upward. So the lowest point is at the front of the control room, and the highest point is here back. We're going to build all sorts of soffits in here. Our soffits are inside the box in box because we don't put chipboard on them. It's 3 layers. These guys, they get insulation installed between them. There's some lighting holes that we box out and do some trickery to. And here you can see there's a window on mix left, and the guys put up some staggered gypboard just so they could fill out my bass trap up here, which is above where the monitors are and goes all the way across the room. One detail that I wanted you to see is that this gap we filled with a heavier duty foam just because people were walking on it, and whenever we put something on top of it, they would just kick it away. And you can see the white foam between the 2 isolated floors. and these are the inner studs, and the outer studs are over here. So everyone see that? You can see that's a vestibule stud, that's a control room stud, this is a control room stud, over here is a live room stud. This is doubled up because there's a big window right there and heavy glass. And then each one of these two studs in the window gets its own window. They never touch. We keep a gap between them. And there'll be insulation on both sides. Anyone have any questions about that?
No, we have a couple of questions about floated floors, but I thought it best to ask in the Q&A. They're just general question, construction-related question. Do you want to take them now?
Yeah, let's take one at least, or one or two. Let's see what we got.
Of course. So Raya has asked, for the jack-up slab, is it a good idea to keep access for adjustment later, as loads may change or for settlement?
Yeah, yes and no. Um, Unless the loads are going to dramatically change, I mean, crazy dramatically. Most springs that you use in these have a huge range of motion. Like, you know, I like to do static deflection, the weight of the slab on the spring to give you 35 to 45%, maybe 50% in some cases of the spring's total deflection. If the spring is 100% deflected, it's not a spring anymore. It's just a piece of metal. So you want to make sure that you have plenty of room. If we go back to these charts, you'll notice that, let's just take a normal thing, that this guy goes from uh, approximately 25 pounds per square inch of um, pad up to 100 pounds per square inch. So each pad, if it's 4 square inches, goes from 100 pounds per pad to 400 pounds per pad. So you have a huge range there. I mean, if you think about what it takes to, if you're only coming down to, you know, here, to get 30% deflection, right? Um, if you're only coming down to 30 pounds or 35 pounds a square foot, you can go up to 90 or a square inch on the pad. You can calculate pretty quickly that it takes one big change. Now, does that happen? I'm sure it does. But if someone needs to, they can pull up whatever floor you put down and redo. I mean, if they're going to redo that, they're going to redo the whole room. They may pull the slab out. I don't even know. So, yeah, I haven't seen that to be a problem. Most of these bolts have a little thing where they're sunk into the slab so you can put down your floor, it's flat. And we use a datum. So in the worst case scenario, you could cut holes and access it again if you need to bring it up or down. If you have to change springs, you're pretty much, you're replacing the entire floor. It's really hard to do. I hope that answered the question.
I'm sure it did.
You got one more?
We are already have a lot of questions, as much as you want to answer right now.
Go ahead. Yeah, let's answer one.
Cool. We have a question. How do you mount the kip pads to the floor, and how do you mount the side walls without rigid connections to the outer walls?
Oh, great. What a great question. We don't. How do you like that? Let me find this picture. I don't. You see this? These kip pads. This comes in a roll in fiberglass. It's just a big roll of fiberglass with pucks every 16 or 24 inches, and you just roll it out and let it sit there. I don't glue them. I just let them sit there. The weight of the floor, they're never going to move. So we don't do that at all. Then when we go back and we put a stud on here, this stud gets nailed into the floating top 3 layers. So here's a stud runner, and that stud runner gets nailed into this wood uh, um, cement board and plywood sandwich. So we just screw it in. It's not going anywhere. As far as the walls go, it's a little bit different because when you have walls, you have sway braces that take the lateral load. And this is, here you go. Watch this for, you want to, no, discard those. Room acoustics, building acoustics, unibrace. I just got to find it. Unibrace. It's under you. Right. So that's what a unibrace looks like, right? And you can put flanges on both sides or one side or the other side, or you can have this. But generally, these are the ones we use. And you can actually make them longer or shorter. The point is that you can attach this to the wall with 2 screws and then attach it to your stud. So what we do is we try not to attach them to the wall except for using resilient lateral sway braces, and we only use those as needed. What's really interesting is that in this room, where I'm about to show you some pictures, because we're using 6-inch studs for the sidewalls, and we used a heavier gauge, and the spanned across the room with 10-inch joists, we didn't have to use any sway lateral sway braces, mostly because Colorado doesn't have earthquakes. Got one more?
Yeah. Although before moving forward to other questions, I had one follow-up question from this section. That's directly from my own for my own personal. Um, what do you think about not mounting side walls laterally to the existing walls and instead letting the lateral load taken up by the structural isolated ceiling?
I'm sorry, say it again.
Instead of mounting the side walls with the lateral load shared on external walls, like the way you do it with resilient braces, instead of doing that, what if we not screw the side walls to the external walls and let it them sit on the floor only, and for the lateral loading part, let it taken by the isolated ceiling, the spanned ceiling?
Yeah, that's what happened in this case. That's what I was saying. There's no. I'll show you this design in a minute. There's no sway braces. There's no lateral load. The box is so stiff and so big, it's totally fine. It doesn't need them.
Yeah,
But
I wanted to ask you, what do you think is better? I mean, like for me, it seems like it's much more easier to calculate, isn't it?
no, it's the same.
Not?
It's easy to calculate either way.
Okay.
Yeah, I don't think it makes much performance difference either. Excuse me. Okay,
Moving
got
forward.
2 rooms side by side. This is a studio underground in Hollywood. This is going to open in April. I'm very excited about this. This room. So here's an option. How about no stud and have the side walls isolate the chipboard for you, because you don't need that much isolation because there's a big, thick, heavy concrete wall here. So we save the space of a stud by just putting these clips and the channels in. Can you see them? Yeah, you can see that. Isn't that beautiful? And then you put some, you put some insulation in here. I guess I'm supposed to make this a thing here. Like that. You can see that this is 1-inch wood. These are about, I don't know, it's a 1/4 inch to the back. So you can slip an inch and a half of fiberglass behind here, and then just screw your chipboard into the wall. Saves a bunch of space. And in this case, we really wanted to save space because the space that we were promised we didn't get by our concrete guys. Here's what that looks like. There's the channel. Now, here's free advice, guys. This one has 3 layers of gyp on one side. It's sitting on an isolated floor, the stud, and this is a non-critical room like a lounge or something. So we just put instead of putting a second stud, we just put an isolator and a channel, and there's fiberglass in here that you don't see, and 2 layers of fiberglass. So this is a 5-layer wall with one stud and a resilient channel. Right? Determining what you need and what you want to do in terms of the program is a big part of saving money for people, which they always seem to appreciate. This is the entrance to go downstairs into the underground studio. And we didn't have room for 2 studs because there's limits on this. So we hung these channels. We filled all this with fiberglass. The red ones are the wave hanger ceiling, which you're going to see in a second. And these are all non-stud walls or existing stud walls, but they're isolated so sound won't get out. There's no real sound coming up this stairways from the studio, and there'll be a door there. So I wasn't so worried about it, but I just thought maybe they're going to stick a guitar amp in there, and we'll just throw those up. It's kind of a cute design. Here's an interesting case, and you guys can decide whether I was right or wrong here. I'm going to let you guys decide. So this is that basement studio for a producer in Las Vegas. And her big concern was 2 things. Sound coming from the live room over here, right, where the green arrow is, into the control room. Okay? So that's issue number 1. Issue number 2 is this is her house. She lives upstairs and she wants to be able to work all night at full volume and not upset her friends or her boyfriend or whoever's upstairs sleeping, her partner, whatever, right? So how do we do this? And what I ended up coming up with was a double stud wall with an isolated floor for the control room, for this vestibule, and for the live room. 3 separate isolated floors. A double wall for the front of the control room all the way here. So I can show you. This is a double stud wall, and each one is sitting on an isolated floor. And the ceiling for this room is spanned this way. And again, I'm spanning the small way because it's much safer and much easier and cost less, because long studs are really expensive. And there's a sag when you span, however many feet it is. You have to limit that sag. There's code in the US, and it has to be safe. So you're always better off going the short way. Now, you'll notice that there's a wall here. This wall is inside the isolated box in box. Let me see if I can, I put this in the wrong spot. Click on here. Highlighter. This wall, can you guys see this wall? So this is what we call out of sequence construction. The guys who do the framing come in, they frame the thing, they put double walls up here, they insulate it all. Then the drywall guys come back, they do all the drywall all the way around and the ceiling. And then the framers come back and put in framing for this wall, which has no gypboard in it. This whole thing is a base trap, because I didn't have height to put one in the front of the room like I like to do. So this is a base trap, and this is a diffuser. We'll make a diffuser purple because they're cool. That's I guess it's about 8 inches thick, and it's a diffuser that sits on the center line, but there's no chipboard behind it. It's an open frame above it, below it. There's a soffit above it that comes across the room. So when you look at this room, you'll see that you don't see that that's a fake wall, but there's a ton of absorption in here to really control low frequency modes. Kind of a great sounding room. I'm really pleased with it. This is what it looks like to build this thing. It doesn't look it looks complicated because it's complicated. So let's start at the bottom. This is the doorway to the vestibule. This is our single stud that has resilient channels on it for the control room and the vestibule. This is the double stud wall that has this piece of foam in the gap between these, right? If you look in here, you can see that this is the inner wall for the control room. This is the outer wall for the live room, and both of those get completely independent something. Windows. And there's tall window here, and there's a no window on the other side, and a small window there. So that's the control room construction. You'll notice two things. This is really hard to see if you're not familiar with it, and I have more pictures coming up. But inside of the existing ceiling joists, can you guys see these studs hanging down that I'm showing? Say yes.
Yep, we can.
You can. Okay. If you look over here, I don't know if is it gonna let me draw? If you draw in here, you'll see that there are metal studs that hang down 1 inch below the existing wooden studs. That's an existing wooden stud. That's a metal stud. You know, there's an existing wood stud here. I drew the thing too thick. There's a metal stud. And those metal studs are held up by the sidewalls. They never touch the ceiling above. How cool is that? This woman produces rap music and hip hop music, and they monitor about 114 to 118. And she had people sleeping in bedrooms above here, and they couldn't hear it. Yes. So cool. Anything else to note here? Nope, I think that's it. This is a ISOMAX channel that's in the wall, and they put the fiberglass in. These are insulation hangers to hold the fiberglass in place, and then they just screw the chipboard into here, and that chipboard is going to meet this chipboard. These are wave hangers. We'll talk about those in a second. For ceiling hangers, I love these guys. They're thin, they're cheap, they work. I'm very, very impressed with that product. It's a really good one. So there are many types of ceiling hangers, right? The most common ones you'll see are spring and neoprene hangers, and they come in every configuration. This one is trying to use two smaller springs so that it's not as deep. They get deep. The other thing is you have to be really careful about calculating the spring deflections on these. And when you use smaller springs, you have less of a error range. So you got to be super careful. The other thing is, and this is important, you got to make sure that the contractors use the right colors, because different colors denote different spring constants, the different weight that they're going to be deflected. Here's a fancier one. It's a little bit more constrained. It's a cool kind of bigger 2-inch deflection or 4-inch deflection, depending on how heavy you want your ceiling to be. These are 1 inch deflection. Well, I think there, I wanted a few more. I showed you this already. So this is a studio in this is a studio in Maryland, one of my all-time favorite studios, and one of my all-time favorite engineers, Charlie Pilzer. He and Dave Glasser have very similar studios that I designed, and they both won a bunch of Grammys in them. And you know what? Neither one of them has let me keep one of their Grammy trophies. I can't believe it. Disrespectful. Anyway, you can really see that this guy, they put up a vertical. You can do that. We put a wood block up here because I don't like metal on metal connections, and screw it in. This one's fine because it's flat. You can see the wood there. But these guys are not connected to the ceiling above. The isolated walls are on the isolated floor. The isolated floor in this room is different than this room, is different than that room. That white foam really shows you the difference. Here is the blocking for a window detail. I think that's it for this one. This is the room that I just tried to show you with the spanned ceiling. And what this is doing is we built our sidewalls and we put our span ceilings slightly lower and next to, but not touching, the wooden existing joists. And that's because it's a low ceiling. This is our friend Brent. He works for Google now, and he's a great guy and great studio tech and master of studio wiring, and someone I'm always thrilled to have on our projects. Again, we put a piece of wood up where these guys come across because the screws hold tighter into wood than metal on thin metal on thin metal. Is there anything else to note here? Not really. This is the front of the room. We have a window here, and we put a video screen the same size as the window here because that's into a storage closet. So this is a more complicated ceiling. This is the ceiling with the room with the octopus in it. It has no sway braces and no connections to the outer walls because these are 6-inch studs and these are 10-inch studs going across the room. And we tripled it up here and we tripled it up here. Can you guys see that that's tripled up? And we stuck insulation in the gaps so that they wouldn't resonate. And then we did a raised part of the ceiling like that. This is not finished, obviously. This was just so they could do some testing. But this is an acoustical soffit, and this ceiling is held up by these side walls, which have no connection to the outer walls. However, to do that, you have to be outside of an earthquake zone, and you have to use thick studs, so you give up space. That should tell you why we don't do it a lot. I don't think this picture was not from yesterday because this is all chipped up, but I was at this studio yesterday. This is a milking barn on a farm that we're turning into a really wonderful studio. We're standing in the live room, and the way this live room works, it has a combination wall ceiling. The walls, the knee walls that go from the isolated floor up to this point are stud walls, and then they meet a wave hanger ceiling, which is a clip that holds channels that you can use on an angle. And then we use the same thing up here. This is just the wooden framing, and I'm going to pull up some pictures real quick of this because I didn't get a chance to. Oh, I can show you these pictures. This is fun. Um, this is what I started with. Anyone live on a farm? This is a place where the cows that live back over here come and they went in this side and they got milked. And so we had to replace this roof and this floor. And that's what it looked like when I started. That's what it looked like when I started. That's going to be our reverb chamber. Oh, come on. Someone ooh and ah, man. That's cool. You ever hear of a cow silo as a reverb chamber? Um, Trying to convince people that they had to rebuild their entire building. And this is when we got started. We took the roof off and put a new roof on. And in order to get the ceiling height I needed wide enough, we put dormers into this building. And this is the spanned ceiling in the studio room. And again, this guy is slanted upward. It's a little hard to see because of the photo angle, and then flattens out because we ran out of room above it. Um, this is the main entry into the control room from a vestibule. That's looking backwards. You can really see the ceiling go across. And then at the front of the room, there's a bass trap that goes 4 feet up above where the monitors will be. This is mechanical stuff going above us. This is the windows into the live room. This is the live room. This is one
Sam,
picture.
Sam, are you still on the same slide? Because it seems like this presentation is frozen.
All right, let me try to. Oh, it's supposed to be giving you, hang on.
Yeah.
It's supposed to be giving you, hold
Participants
on
were
for
saying
one
for a long
second.
time. I just
Yeah,
thought maybe it was showing only that.
no, no, no. I was showing you all these cool things. Riverside FM studio. Here, share. There it is. I'm going to share my screen. I'm going to share my entire screen. I did the window. Now I'm going to do the whole thing. Entire
That
screen.
should do.
Okay, this should do it. All right, I'm going to start that again because this is interesting, I think, to me anyway. This is what we started with. This is what it looked like on the inside on the second floor. That's the great recording engineer, David Hewitt. Um, Amazing, amazing. If you haven't read his book, you should read his book. It's great. That's the silo. Can you see all this?
Yeah, perfectly well.
Oh, you can see this.
Hmm.
Okay. That's us discussing how much it's going to cost to rebuild this thing. Um, this is the start of the rebuild. This is we put up two decks, one on each end, so you'd have outdoor space. The entry is going to up a stairway and in through this door into a vestibule, into the live room, and through another vestibule into the control room, or you could come in through the lounge, up, and through the vestibule into the control room. This is the control room into the vestibule. That's the lounge. That's some mechanical stuff. There's three windows. There's more windows out here. That's the entry vestibule. This is the framing for the bottom part of the wall, which will meet the isolated top part of the wall. This is our kit pad, plywood, honeycomb, plywood, cement board, plywood. And then we got some other material that our contractor found that uh, he got it and he wanted to use it. It's supposed to have sound properties. I didn't think much. In this room, we put plywood behind two layers of gyp because we're not really near anything else, and we've got plenty of double stud walls, and that way you can screw things in. Here's our bass trap. This bass trap goes 4 feet up above um, the ceiling height here, and it goes all the way across the room, and the monitors will be here and here, And so off-axis low frequency energy will come into that. And here's more stuff. This shows windows tilting upward. People used to use windows tilting downward, and they thought it was great because why? Because it was better for lighting. But in the 1950s and 60s and so forth, lighting was not as good as it is today, and you can avoid glare, very easily. So we always tilt upward away from the mixed position in the inside and up into the ceiling where we have a soffit with lots of materials and diffusers. So I encourage you all to tilt your glass up. This is the vestibule. I'm coming from the live room. I can walk and make a left into the control room, or I can go straight into the lounge. Double wall construction, double window construction, and an entirely soft ceiling. And that's the end of that section. And I come to our library here and show you the pictures I took yesterday. We're starting to do trim. We're starting to do the soffits. That's the base trap with some supply air. We do very slow supply air out of here. It's like 250 feet per minute. That's like 72 inches wide. So it's 5 by 72. So it's quite a lot of air dumping down very slowly. And when you go to the back of the room, it gets pulled up by 3, 2 pointed downward and 1 pointed flat to give you no drafts and nice slow air circulation in the room. For those of you guys who know me, you'll notice that this angle, can I mark on this angle? This angle from, you can barely see this line, to this angle is different than this angle. These are asymmetric rear corners. If you look online, you can find our research into asymmetric rear corners in control rooms, and it does an incredibly good job of controlling modes from about 70 hertz, 65 hertz, up to about 110 hertz. So I really like that. That's Ken Berger, who came with me yesterday. He's the founder of EAW and a good friend of mine and someone I care about. This is going to be the coolest soffit configuration I've ever built. It's a triple triangular with open slats on the horizontal, open slats on the verticals, and fabric on the horizontals. So it'll be slat, fabric, slat, fabric, slat, fabric. And this level goes all the way around above the control room to the other side where we're doing the same thing. More windows to the live room, showing you the upper glass. This is part of the ventilation for the control for the live room. Tried to make some cool pictures. They've started on the other side of the room. This is how the air is getting in. We're doing a cool bench here, and you can use the bench for sitting. Originally, it was going to be storage, but we decided to make it air conditioning. Lots of pictures of vents. These are cows. That's a bull, I think. There's the studio. It's literally on a working farm. And you can see the studio in the background. And that's that. I can show you a couple of pictures. Let's go to this, and then we'll do some questions. Oh, I know what studio I can do show you guys that you'd like. I think this one is going to do it. Here we go. I got it. This is a studio in Las Vegas where they have a retail store with the largest wall of hats in the world. And this guy's job is to ride up and down during the day. It's not construction, and pick you the hat you want from the wall of hats. Okay. Let's go back here a little bit. This is the space we started out with. I didn't necessarily think this was a great spot for a studio in a store. So we came up with some ideas to make it more interesting. This is at Caesar's Palace, so there's all sorts of walkways and hidden walkways and all sorts of regulations. You'll notice that we used our spanned ceiling again, which I think is a really good way to go. When you work with contractors and they put up double walls, even though they have sway braces here, this is the unibrace sway brace there and there, they put this piece of angle up so it wouldn't move when they started putting up chipboard. And I went by and spray painted them all red and counted them all to make sure that we didn't end up with extra things bridging ours. So this is one of the things you have to look out for. The penetrations, this is a duct silencer. I don't know how many of you guys know about inline duct silencers. There's another one. And some framing. This is the great and terrible Zoe Thrall. She's like the Wizard of Oz and construction guys. Zoe is one of the great women of our industry and someone who's just amazingly good at what she does. When we came down from this shaft, we're coming down with an inline duct silencer. You can see there's a metal piece in here. And if I say price, rectangular, where'd it go? I've only got 72 windows open, so it shouldn't take too long to find it. It's in preview. Right. So what a duct silencer is just a duct with different types of materials in it to attenuate sound. And what we do is this is maximum insertion loss. So if you do them flat, you get the most acoustical attenuation. If you branch one so that it gets faster a little bit, you get balanced performance, you get some attenuation and less pressure drop. And then if you do it all the way across, you get less pressure drop. And this is usually for high air velocities so that you don't make the fans work harder. And you can group these together and you get extended casings and you get all different parts in here. So this picture happens to be from one of our corporate projects. They can come in almost any size you want. There's some limits, but they're not real. This is the medium velocity where in our case, the velocity of air is always 500 feet per minute or less. The silencers come in 3 foot, 5 foot, 7 foot or more. And the pressure drop is the resistance. That's here, pressure drop. And so for a 3 foot silencer, you get almost no pressure drop. It's actually hard to measure that little, but you don't get any low frequency absorption. At 5 feet, you get 10 dB. At 250 hertz, you get 1920 dB, and so forth. If you go to things that have more pressure drop, you can get more attenuation. So we try to balance the resistance to airflow so that we don't need bigger air conditioning units. And we try to put these through walls and ceilings so that we can get low noise and not destroy our isolation. This is a medium velocity silencer that goes up higher. We almost always stay with the um, uh, maximum 750 feet because we almost never want to be anywhere near 750 feet in studio design. So this is from a company called Price. There's a company called Vibro Acoustics that makes them. There's a company called IAC. I don't know who is in India doing silencers, but the quality of silencers has improved dramatically over the years and is really become great. It's really become great and they've become less expensive. The other nice thing about these span ceilings is you don't have to go all the way up and shoot a Hilti clip into something and then bring things down and have them hanging. It makes it easy for your HVAC and electrical guy to work up there. They can just slide the joists out of the way until they're locked into position. So it's a very construction friendly design. This is a mistake. Look at this. You guys see this piece of foam here? They covered over my gap. I was like, guys, cut this out. So they cut it out. You know, people who haven't done this before make mistakes. Like that guy. That's a mistake. And learning to spot those is a good skill to have. And here you can see they left spaces for the mechanical engineer, the electrician, and anyone else who had to work in the ceiling to get up there easily. That's the control room. This is, oh, no, I'm sorry. Got to see which way we are. Yes, that's the control room. We're in the live room here. This is, that's the live room. More vents being boxed out for us, more double wall construction. You'll notice that the outer wall here is 6 inches and this is 3 5/8. And the reason for this is this guy's got to be like 25 feet tall and this one only has to go up so far. All of this framing is inside of our box in box for our soffits, our acoustical soffits. This is an STC 63 4-piece slider. This is an STC 63 3-piece slider. This opens to the store. That's the wall of hats downstairs and across the way in the same store. And they can open all these windows and have people do performances here, mostly rappers and podcasters. This is another bass trap above the monitors. Works incredibly well. Just love this. My dear friend Zoe picked the equipment for this. Her buddy installed it. I can't say how lucky I am to work with Zoe. She and her husband are just two fabulous people who I have the utmost respect for. This is our electrical conduits for the studio. There's me doing whatever it is I do, hanging out with the guys. This guy works for the store. This is our project manager, Zoe, and some of their guys putting in air conditioning. This is what it looks like. I put electric glass on this so that it can go electric, it can go opaque or clear instantly. This is the STC 63 control room. And again, they wanted to be able to do podcasts from in here and mix in there at the same time. I like these good panel diffusers a great deal from Real Acoustics. My friend Richard Lenz developed these, and I think they're just brilliant. I used more traditional QRD styles up there. That's an emergency exit. These are bass traps that I put on the floor next to the monitors, behind the monitors, and we lock them in place with a triple raceway, video, audio, and power in 3 raceways. A traditional QRD diffuser, the store being built. That's the power going to the electric glass. I'll see if I can find a picture of the electric glass for you. The store is called Culture King, so if you go to Las Vegas, you can go see it. There it is, pretty much ready to run. Again, the team. And while I designed this, we did have an architect, we had structural engineer, mechanical engineers, Zoe doing equipment selection. There's just a boatload, electrician who was great. A lot of people to build a studio. This is their basketball court with color changing LED lines. It's a fun store to visit. That's our electrician. This is the first client on opening night. He did a little performance. It was awesome. This guy is the owner of Culture Kings, and he was happy, so I'm happy. Is there anything else? They made custom shoes. This is a guy who did the first record there, and man, that guy's got some talent. He's serious, and it's funny because I don't listen to much rap or hip hop, and he doesn't listen to much of the music I listen to. And we spent a full day listening to each other's music and talking about it. And I just love this guy, man. He's so cool. Anything else to see in here? Should be a video showing. Oh, this. Can you guys see video? I don't know what you guys thought of that, but it blew me away the first time I saw it.
This is really cool.
Yeah, I mean, that's 4K video. I'm trying to find this is us tuning the system. That's Tyler. Tyler actually did most of the drawings for this, so we brought him out to Las Vegas to hear it and to. That's from my iPhone, so it's not gonna. But here you can see that no one really sees those bass traps. Color changing lights. You guys want to see one more? Oh, that's Richard Lenz from Real Acoustics. He bought a fancy camera and was shooting videos of us. You guys want to see one more that uses all these techniques we talked about today?
Yeah, why not?
Well, it's up to you, man. Oh, let's do the woods. I like that one. I'm not supposed to show you. I've done several projects in Woodstock, and I want to see if I can get them to separate. Yeah, there you go. I'm not supposed to show you the secret project in Woodstock. So this is another crazy project where someone bought an old kids camp, and this was the I don't know if I have a picture. Well, I don't have a picture from outside. I don't have 115 pictures. I'm missing a bunch of pictures. Wonder if I put them someplace else. All right, well, whatever. He bought an old cabin, an old camp. So it had a bunch of cabins on it. And where you see the concrete floor here, we built this on. So the thing was just a rectangle, and we built a T for a control room on it. And then this would be the lounge, and the entrance is over here. I'm standing in what would become a live room. And what was really interesting, um, there's some loft spaces and some other spaces. We basically had to rebuild the whole thing. But in order to make it work for sightlines, we actually had to put the front of the control room into the old building. And that was not trivial. That would turned out to be require some design effort. Um, this is a window at the back of the control room. This is a window at the side of the control room. And you can really see the slope here and the flat part. This happens to me quite a lot. We slope up as high as we can and then we roll up. I don't want to come lower at the front. And this goes up to that bass trap that we were talking about earlier for catching bass. And you can really see the slope downward there and the double wall construction. There's the existing room, and these reddish brown joists are sitting on the side walls, and they are, in fact, our ceiling joists. And this is the bass trap that goes from the front wall comes flat, goes up, comes over, comes back down, and then it slants up. It slants up there, so when you see the finished picture, you won't notice it as much. It's different, it's fabric. But you can really get to see how this comes in, and it's even though it goes into the existing building, this inner wall is completely separate from the outer wall. So we did double wall construction at 2 layers. So there was a step up between our slab and the slab for that room. And you can really see that here, double wall construction. Nothing touches. The contractors were incredibly helpful in making that work. We kept that window, some funky angles, and there's Tyler doing what he does. And this is the main control room, looking into the main control room. And someone dropped a piece of wood in my gap, and I threw a little hissy fit. No, not really. I said, could you move your wood out of my gap, please? They doubled this one up because that's where the bass trap starts. They doubled this one up because that's where it flattens out. You can see that here. And this is the sway brace that was required by law. We don't use too many of them. We use the minimum ones. There's the old building. We cut these windows in it. We cut a bunch of new windows in it too. You'll see in a second. Insulation. He wanted to use this special ecologically sound insulation, so we did. That's my apartment. I'm sitting here right now. Those are wave hangers on a slanted ceiling. We put a little screw in the center, a flathead screw, to hold them on an angle. They work great. Big window, 2 smaller windows. Everything's gypped up. This is a piano room. It's a little small for a piano room. Looking into the control room. On the peak, we have a bunch of diffusers that he owned. There's the bass trap. I hope you guys are all going, ooh, what a great idea, Sam. Thanks. I appreciate that. We fill that with every type of bass absorber I can find to try to get the best combination at the frequency range we think we need. That's the boathouse. That's our building. That's the new control room. We built this thing onto this building. And That's the owner of myself, who's a buddy of mine, and frames. And you can really start to see, again, once we put the jip up, the soffits go in because they're inside the box and box. You can really see the gap here. Um, these rooms are not rectangular, they splay outward. This is a soffit in the live room. This is a soffit in the control room. A bunch of hanging baffles he owned, a hanging diffuser, piano, duct liner along the edge. More stuff. Now it's getting closer and closer to usable, and they started moving equipment. Todd has an amazing collection of amplifiers. Did I mention I love these? These are called good panels, GUD. And boy, they come in 2x2, but I usually buy them in 4x2. And they're mid-high frequency diffusers, and they're 2 inches deep, and they're just great, and they look cool, and they sound great. I do not like skylines because unless you're directly under them, they don't really work off axis, but the owner owned a bunch, so we used them. Tyler and I doing what we do, ATC monitors in front of the glass, beautiful view, mix left, beautiful view, mix rear. We designed the diffuser to go around. I like that a lot. I love natural light. That's the bass trap. This is all absorptive from the soffits. This is a cloud over the mix position. Tyler. These are some guests that I brought for a view of that. So I hope this was a practical and interesting guide for you guys.
I'm sure it was.
Is anyone left?
Of course, there are. Of course, almost all of the people who joined, except for.
Lucas. Lucas and I are going to become friends, man. I love his
Yeah,
questions.
these are some really great questions. I was about to.
Hey, Lucas, thank you so much for attending today, and I hope it says this is the deal. The question Lucas asked, which is great. Follow-up question. The duct silencer reduces the noise inside the duct. How do we stop sound transmission around and through the duct? Isn't the duct just a hole in the wall with thin metal walls? Yes. Put a duct silencer through the wall. Use a neoprene gasket if one side is, if it's a double stud wall, so that it's isolated from the walls. But what I do is the standard duct silencers, standard ducts are usually 22 gauge steel. Is that the same in India, Vipal?
Not really. I'm not sure because I've never used metal ducts. As you know, I use flex ducts, so no idea.
Yes, that's because he's wrong. Anyway, you can buy silencers with 18 gauge steel or 20 gauge steel, thicker steel, lower number is thicker, and you put them through the wall. Let me see if I have a duct penetration detail close by and handy. I knew I was going to need one today. That's not one. I don't even know what that is. Right, so here you go, check that out. This is ductwork, but it should be a silencer, that should say silencer. And you put,
Sam, we can't see anything. You're not sharing anything.
oh, I'm not sharing the right screen again, hang on. You guys, man. Entire screen, that guy, share. Now you're gonna make me find it again, I know you guys. Can you see it?
Yep, perfectly.
Right. So what we do is we put neoprene or other material. There's a metal support for the duct. We put the duct silencer through the wall so that if it's through a single wall, through a double wall, we do this separately for each with a gap between them. The point is that break in and break out noise should be limited. Like usually we do a turn or we try to come as far straight as we can to get better airflow and then turn into a soffit. But the idea is that the thicker metal keeps the sound out. These are lined, and if you have a 5-foot duct silencer, it's hard to just talk through it. So we go out of our way to put duct silencers through the wall, and that's really the key to it. Let's see what else I have. Yeah, I don't want to pull up AutoCAD. Yeah, the amount of attenuation you get for stuff going down is almost equal to the break in, break out noise. So as long as it's sealed, you're good. I hope that answers that question.
I hope it does. Also, Lucas asked, and I guess a couple more people asked the same question about foam separators. I can't find the question, but the question was essentially about do you guys remove the foam separators after the build is complete between the two floors?
No, just leave them there.
You don't?
No, why?
Um, I'm sure like whatever you're using is very well calculated. But in my case,
It,
I've
it,
seen.
it, it has zero transmission. If
So
that's causing transmission, we're building the best studios in the world. If anyone can hear, it's just nothing. It's like air.
so is it a specific foam?
You know what I do? I take the leftover SR board and I just stick it in there. I couldn't care less. It doesn't transmit sound. It doesn't, you need something like it's gonna really. Patrick wanted to know what the rear wall diffuser in the Culture Kings room is. Uh, that's a good question, Patrick. Can you see this? Can you see my map? Paul?
No, not. Can you hear me? No.
Yes. Can you see my
We can't hear
map? You can or
you. You're
can't see? Can you see the map or not?
Nope, nope, nope. You're not sharing anything.
Oh, that's right, because I stopped sharing. Because I'm greedy and I don't like to share. Share. Screen again. Entire screen. Go ahead, share that. All right, you should be able to see my map any second here.
Fine, first.
I have to go and remember what it was, so I will find it any second now. Caesar's Forum Shops. The diffuser, this diffuser in the control room is one of their studio diffusers. It doesn't have the high frequency stuff like the 450. Maybe this is the 250 or the 350. I can't remember. And in the other room, I did something that I thought was kind of cute. I don't know if it was a good idea or not, but I took 4 good panels and I, I stuck them on the wall, 2x2 good panels, or 6 of them, and I just put that there because it's got a bass trap below it in a bench, and it's got a soffit above it. So I didn't think too much stuff that wasn't coming in at direct access was going to get through there. So I just went for it. I hope that answers that. Any other questions?
We had a few earlier related to floating floors. Let's take that until
Hang
we get.
on. I'm gonna read these real quick. How about all those flat windows in live rooms? Are they tilted? Yes, they're all tilted. Um, all of the windows on the inner walls, the ones in the Milk House studio have not been installed yet, but I always tilt windows on the inside wall. Christian Stonehouse, thank you for the kind words. I really appreciate that. David Schumann cannot see. I hope you got that worked out. Um, Patrick was talking about the good panels. Yep, they're good panels. Great. What else we got? Anything else before we call this a day?
I'll just quickly scroll it back to the older questions that we skipped during the flow section.
All right, go ahead.
Um, this one about sealing. I wanted to know how sealing was supported on the previous slide whenever it was one without connection. Oh, it just got scrolled down. Let me get it back.
What's this? Oh, yeah, there's no flat windows. Awesome. Where was the ceiling?
Actually, because of the continuous charge, the chart is just getting scrolled down. I'm scrolling back to find the question once again.
As for rubber pad, the deflection is in kilograms.
Yeah, this one.
No, it's not mass. Yeah, it's not mass per puck. Yes, you can figure out the mass per puck, but uh, if you look at that chart, most people assume it's mass per puck. Simon asked that. Um, and after that, you take the static deflection. Yep. But that is for 1 squared, so you divide the frequency equivalent. Pretty much, he's got it. What you wrote, Simon, is pretty good. All right, what do you got now?
There's
Something
this question about from Tonchi. She asked, "I wanted to know how ceiling was supported on previous slide, one without connection to the upper floor."
from the sidewalls. We've seen 20 of them. I can go back real quick and share again. Oh, it's you are sharing my screen. Okay, so like for example, in this case, this is a really good example because here's a room and they were working in the ceiling and they put up 2 ceiling joists to show people where the ceiling was going to be. And then they went back and put up the rest of them. So this inner stud is holding up this ceiling. And on the other side of the room, the same thing. That's the same as it was here, are all the studs, typically on 16-inch centers. And they all are supported by the sidewalls, which are sitting on the isolated floor, which is why we doubled up the number of pads. You should know that I don't ever really use rubber pads in isolated floors. I either use springs for heavily massive, giant floors, or I use kit pads. I haven't done springs. The only place I really do springs is in gyms. And uh, uh, I don't love springs for that. We use springs for ceilings when we can't span. There's a limit on how far you can span joists until they get really, really big and really expensive, um, and you don't have space anymore. So so if I can't use a span joist, then I use hangers, spring and neoprene hangers for ceilings. Anything else?
There's a question by David about wall unibraces for larger rooms like 25 by 30 feet. I hope it's feet. He hasn't mentioned, but would you connect the walls via the ceiling joist or use the ISO clips and unibraces for walls?
Um, I have a question about the wall unibraces for larger rooms. Um, yeah, you've seen a couple of larger rooms. The big room with the octopus in the floor didn't require any unibraces because we used big studs. I almost always use. I've never used unibraces on a span ceiling joist ever, never, because I don't want to connect them. I don't want any connection. There is one place in California, in Los Angeles, where they made us put in aircraft cable that I put um, rubber around the aircraft cable, and we shot a clip into the ceiling above, and then we put it around the joist so they couldn't fall, but they weren't taut or anything like that. It was just earthquake safety. But yeah, no, I've never put a unibrace or any kind of resilient channel on a ceiling joist. Let the sidewalls hold them up.
Makes sense. I
All right. Listen, guys, um, Vipal will give you his cell phone number. Call him in the middle of the night and ask him any questions you have. Please.
That's exactly what I was going to say for you in your introduction, but you didn't let me give you an introduction. You just started straight with the session.
I don't need an introduction. I don't care.
You don't need an introduction, that's right, but I really wanted to do it this time. Last time we did the
Well, you
webinar,
should
I
have told
prepared
me.
an.
We can wait till everyone gets off, and you can tell me that I've done wonderful things. I don't know.
I
Like,
mean,
hey, I'm super proud of the work we do, concert halls and recording studios. I feel like I'm dedicated to sharing information and sharing techniques and details because the generation before me hated it. And I thought it was stupid then, and I think it's stupid now. I think we should all share and learn together. And I hope you guys all build something better than I build. So I have to learn how to be better. We all push each other. I do have, I know Facebook is not cool, but I started so long ago, and I see Dan Fitzgerald's here. He's a regular contributor and has a lot of good things to say on there. So you guys are more than welcome to join. It's called Acoustical Details and Discussion, I think. It's a Facebook. Is that what it called, Nicole?
I guess acoustical construction details and something like that.
Acoustical Construction Details and Discussion. That's what it's called.
Yeah.
Um, I try to give it 15 minutes a day, sometimes more, sometimes less, but it's really fun. So, and there's a lot of really smart people on there who really seem to uh, are really trying to do things well. And we don't always agree. So it's kind of fun. The only rule is, be friendly, man. Don't be ridiculous. Don't insult anyone. We all start out with stuff we don't know. I have a ton of stuff I don't know, and like my friend Zoe knows more about wiring and studio equipment than I'm ever gonna know. And I have my a bunch of people I work with who know so much more about construction. And you know what? I'm okay with that. I know about how to get design rooms to make them sound good. So we all share information, we all get better projects. So I would hope that everyone adopts something, some variation on that, and we have a fun time. Thank you guys all for your time. You can
That's
find me
something.
online. Like I say, email, call Vipul so he can you know, I'm gonna find his cell phone number. I'm gonna make sure that you call him in the middle of the night.
I'll be happy to, but like this is something what you just said amongst many other things that I really love about you. And you, even though you didn't let me say that in the introduction, and I know you get super annoyed with praises and thank yous, but anyway, I'm going to just give a bit of it because even though most of the people know it about you, and but for those who are new to Sam in general, or who don't know Sam as much, I've been really lucky to know him and get fairly good, well acquainted with him in the past couple of years after the
we,
first
we
webinar.
met we met online.
Yeah,
You
yeah,
reached out with some good questions. That. It's not like there's any mystery about it.
yeah. What I'm trying, what I want to tell about you is that um, there are all kinds of smart people out there, like all professionals, all super smart, nerdy people, but I've never met anyone genuinely out there ever as much giving as Sam. uh, he gives away so freely. I mean, everybody knows it, but this is just for those people who are joining in for the first time or attending a session with you for the first time. And I wanted to tell about the incident. You must, I don't know if you remember even or not, when I called you up for doing a project with me on MEP and HVAC design, that I want you to do the HVAC designs for my project. Do you remember that? Yeah, I know you wouldn't, but I just called him up saying that we have a problem on a project and I need his help, and the client was willing to pay for his time. And this is something he could have easily charged a good amount of money for it, even when clients are willing to pay. But he was deliberate on explaining to
Hey,
me how I can do it myself.
people
And
people
after
I
the call,
work with are seeing this. Don't tell this story. Now I have to send you an invoice. No, you know what?
I'm just
There
telling
there are
people, I'm just
problems.
telling
There are problems that are simple. This was one, and you just had to think it out a little bit differently, and then it's easy.
Sure, but it's not every day that when you disconnect a call, a professional just sends you an email full of resources and steps of how to do it. I still have that email that you sent my way, and I could just do it all by myself since then. So what I'm trying to tell everyone is that whenever you have a crisis, call Sam, and you will be safe for the rest of your life.
Yeah, just I got to do a big what you call it. I got to do a. Sam is obviously a. Well, I work. I wouldn't say that I'm a hippie because I'm bald, but I have. I have worked for a hippie band for many years.
Lovely hosting a session with you, Sam.
Thank you for your kind words. I will speak to
Couldn't
you
say less.
later, guys. I hope this was fun. Let's all have a great new year and move on. All right.
Happy New Year. Thank you all for joining in. See you guys.